Lise Meitner, Introduction. In the pantheon of 20th century physics, a world populated by titans like Max Planck, Niels Bohr, and Albert Einstein, one name echoes with a particular haunting resonance: Lise Meitner. This isn't just a story about a brilliant scientist. It's a story about a mind so formidable, so profoundly insightful, that Einstein himself, a man not known for casual praise, referred to her as our German Marie Curie. He saw in her a peer, a genius whose intellect was reshaping the very foundations of reality. And he was right. Lise Meitner stood at the precipice of one of humanity's most terrifying and transformative discoveries. She was the intellectual force who first understood and named the process of nuclear fission, the violent, energetic splitting of the atom. This wasn't just another step forward in science. It was a quantum leap into a new age, an age of atomic power, nuclear medicine, and the terrifying shadow of the atomic bomb. Her work unlocked a secret of the universe that had been hidden since the dawn of time. Yet, here lies the gut-wrenching paradox of her life, a contradiction so stark it almost defies belief. The woman who cracked the code of the atom, who explained a phenomenon that would define a century, was forced to work for decades without a salary. Imagine that. While her male colleagues drew paychecks, held prestigious titles, and built their careers, Lise Meitner, the genius Einstein admired, was an unpaid guest in the very institute where she was conducting world-changing research. She was barred from the main laboratories simply because she was a woman, forced to set up her equipment in a cramped woodshop in the basement. This was the reality for a mind that would later hold the key to atomic energy. This initial, galling injustice was merely a prelude, a dark overture to a lifetime of being sidelined, overlooked, and ultimately erased from her own monumental discovery. To truly grasp the magnitude of her journey, we have to travel back to the turn of the 20th century. Science was in a state of exhilarating turmoil. The old, comfortable world of Newtonian physics was being shattered. Radioactivity, discovered by Becquerel and the Curies, had revealed that atoms were not the stable, indivisible building blocks everyone had assumed. They were volatile, mysterious, and held immense reserves of energy. This was the wild frontier of physics, and it attracted the most brilliant minds on the planet. Berlin, in particular, was the epicenter of this revolution, a magnet for talent. And into this fiercely competitive, male-dominated world stepped Lise Meitner. Born in Vienna in 1878 to a progressive Jewish family who encouraged her education, Meitner had to fight every step of the way. Women were not even allowed to attend universities in Austria until she was nearly an adult. She had to be privately tutored to pass the entrance exams, which she did with flying colors. She became only the second woman to earn a doctorate in physics from the University of Vienna. But a doctorate wasn't a ticket to a career. It was just the beginning of another fight. When she moved to Berlin in 1907 to study under the legendary Max Planck, she was breaking new ground. Planck, the father of quantum theory, made a rare exception to allow her to attend his lectures. But even he, a relatively progressive figure, was initially skeptical of women in science. This was the environment she entered, and it was here she met the man with whom her name would be inextricably and tragically linked, a young chemist named Otto Hahn. They were a perfect scientific match. Hahn was a brilliant and meticulous experimentalist, a master of radiochemistry. Meitner was the theoretical physicist, the one who could see the deeper meaning behind the experimental results. He could isolate the strange new elements. She could explain the physics of why they existed. Their partnership, which would last for 3 decades, was one of the most fruitful in the history of science. Together, they made significant discoveries, including the element protactinium in 1917. This work finally earned Meitner some measure of official recognition. After years of working in that basement woodshop without pay, she was eventually given her own lab and, in 1926, became the first woman in Germany to be appointed a full professor of physics. It seemed, for a moment, that her brilliance had finally overcome the systemic barriers of sexism. She was a respected, leading figure in the international physics community, a contemporary of Bohr, Schrödinger, and Heisenberg. She was at the top of her game, leading a department at the prestigious Kaiser Wilhelm Institute for Chemistry. But a far more sinister and insidious form of discrimination was gathering on the horizon. The slow, creeping poison of antisemitism was seeping into the fabric of German society, and as the 1930s dawned, the world Lise Meitner had fought so hard to build was about to be torn apart. This story, therefore, is not just about the discovery of fission. It's about the collision of one of history's greatest scientific minds with one of its darkest political moments. It's a testament to the resilience of a woman who pursued truth in the face of prejudice, and a chilling reminder of how easily genius can be silenced and history can be rewritten. Block 2. Fission, Discovery, and Injustice. The scientific world of the 1930s was consumed by a single, tantalizing puzzle, the atomic nucleus. The discovery of the neutron by James Chadwick in 1932 had given scientists a perfect new tool. Because it had no electric charge, a neutron could slip past the atom's electron shell and defensive positive charge of the nucleus, striking it directly. It was like having a key to the atom's innermost chamber. In Italy, Enrico Fermi began bombarding every element he could find with these new keys, creating a host of new radioactive isotopes. When he reached the heaviest known element, uranium, number 92 on the periodic table, he observed strange and confusing results. The consensus at the time, which Fermi himself promoted, was that they were creating transuranic elements, new artificial elements heavier than uranium. It was a sensational idea, and it sparked a frantic 4-year race among the top labs in Europe to confirm it. In Berlin, the team of Meitner, Hahn, and a brilliant younger chemist, Fritz Strassmann, was at the forefront of this race. They were the A-team of nuclear chemistry and physics. Meitner was the undisputed intellectual leader of this group. She designed the experiments, interpreted the complex physics, and guided the research. Hahn and Strassmann were the expert chemists who executed the difficult task of separating and identifying the minuscule amounts of radioactive substances produced. For years, they struggled with the same confusing results as everyone else. The irradiated uranium was producing substances that behaved chemically like lighter elements, not the expected heavy ones. It made no physical sense. According to all known laws of physics, hitting a nucleus with a tiny neutron might chip a small piece off, an alpha particle perhaps, but it couldn't possibly cause a massive rupture. It was like throwing a pebble at a boulder and expecting the boulder to split in two. The entire community, Meitner included, was stuck on the transuranic idea. But as the 1930s wore on, the political situation in Germany deteriorated catastrophically. The rise of the Nazi Party brought with it the Nuremberg Laws. Despite having converted to Protestantism decades earlier and being an Austrian citizen, Meitner's Jewish heritage made her a target. Her professorship was revoked. Her academic friends and colleagues began to shun her. For a time, her Austrian citizenship offered a thin veil of protection. But in March 1938, Germany annexed Austria in the Anschluss. Overnight, Lise Meitner became a German citizen in a country that wanted her dead. Her life was in immediate danger. Her colleagues, including Niels Bohr and Dutch physicists Dirk Koster and Adriaan Fokker, orchestrated a frantic, clandestine escape. In July 1938, with just 10 marks in her pocket and a diamond ring from Hahn for emergencies, she was smuggled across the border into the Netherlands, and from there to Sweden. She was 59 years old, a refugee, stripped of her position, her home, and her life's work. She landed a position in Stockholm, but it was a hollow one. She had poor equipment, no collaborators, and was treated as an unwelcome outsider. Yet, her mind was still connected to the puzzle in Berlin. She and Hahn corresponded constantly, with Hahn detailing the baffling chemical results and Meitner providing her physical insights from afar. In December 1938, the mystery reached its climax. Hahn and Strassmann had performed an exceptionally precise experiment and found something utterly impossible. After bombarding uranium with neutrons, they had definitively identified traces of barium in the sample. Barium? Its atomic number is 56. Uranium is 92. This wasn't a small chip off the old block. This was evidence that the uranium nucleus had been shattered into much smaller pieces. Hahn was a chemist. He knew his results were correct, but he couldn't explain them. In a now-famous letter, he wrote to Meitner, his exiled partner, "Perhaps you can come up with some fantastic explanation. We ourselves realize it can't actually burst apart into barium." That letter reached Meitner in a small town in Sweden, where she was spending the Christmas holiday with her nephew, Otto Frisch, who was also a physicist. The image is one of the most iconic in the history of science. Meitner and Frisch walking together in the snow, discussing Hahn's impossible result. Meitner, with her profound understanding of nuclear physics, began to calculate on scraps of paper. She recalled the liquid drop model of the nucleus, a theory that pictured the nucleus behaving like a wobbly drop of water. Perhaps the incoming neutron caused the uranium nucleus to wobble so violently that it elongated, formed a waist, and then snapped. It split into two smaller droplets, two smaller nuclei. Frisch and Meitner calculated the energies involved. Using Einstein's famous equation, E equals mc squared, they realized that the two new nuclei would have slightly less mass combined than the original uranium nucleus. That tiny amount of lost mass had been converted into a colossal amount of energy. This was the fantastic explanation. They had discovered nuclear fission. Frisch rushed back to Copenhagen to tell Niels Bohr, who slapped his forehead and exclaimed, "Oh, what idiots we all have been!" Meanwhile, back in Berlin, Hahn rushed to publish the chemical findings. But in the toxic political climate of Nazi Germany, he made a fateful, career-defining decision. He published the paper under his and Strassmann's names only. He omitted Meitner's name, later arguing it would have been dangerous to include a Jewish co-author. While perhaps true, he then spent the rest of his life systematically downplaying her role, framing her as a junior assistant and claiming the discovery was purely the result of his chemical experiments, ignoring the decades of her physical leadership that led to that very moment. The injustice was now set in stone. The woman who had fled for her life had now been robbed of her life's work. Block 3. Einstein's genius, Nobel's snub. The news of fission spread through the global physics community like wildfire. Within weeks, the experiment was replicated in laboratories around the world, confirming the monumental energy release that Lise Meitner and Otto Frisch had calculated on their winter walk. The implications were immediately apparent and terrifying. Scientists realized that the fission process itself could release more neutrons, which could then split more uranium atoms, creating a self-sustaining chain reaction, the theoretical basis for both a nuclear reactor and an atomic bomb. History had been irreversibly altered, and it was all because of a letter sent from a Berlin lab to a lonely exile in Sweden. Yet, as the world lurched towards war, the narrative of the discovery began to solidify around one man, Otto Hahn. He was in Germany. He had published the first paper, and he was actively promoting his version of the story. Meitner, isolated in Sweden and reluctant to engage in public disputes, was left in the shadows. This is where the praise from figures like Albert Einstein becomes so critically important. Einstein, who had fled Germany himself, understood both the physics and the politics at play. His description of Meitner as a genius wasn't just a compliment. It was a testament from the highest authority in science. He recognized that her contribution was not just an add-on, but the essential intellectual key that unlocked the entire mystery. The ultimate betrayal, however, would come not from a single person, but from an institution. In 1945, after the war had ended, the Royal Swedish Academy of Sciences announced the 1944 Nobel Prize in Chemistry. It was awarded for the discovery of the fission of heavy nuclei. The recipient was Otto Hahn, alone. Lise Meitner and Fritz Strassmann were completely ignored. The decision was, and remains, one of the most controversial and widely criticized in the history of the Nobel Prizes. How could this have happened? The Nobel Committee's deliberations are secret for 50 years, and a look into the archives reveals a complex failure. Firstly, there was disciplinary bias. The Committee for Chemistry may have failed to fully appreciate the essential role of a physicist interpreting the chemical data. Secondly, there was Hahn's own lobbying and his carefully constructed narrative, which minimized Meitner's role to that of a subordinate. He accepted the award without making a significant effort to correct the record, a silence that deeply wounded Meitner. Finally, there was likely a degree of ignorance on the part of the committee about the true nature of their collaboration, especially how it continued so intensely even after she was forced to flee. They failed to see that Meitner wasn't just an analyst, she was the intellectual architect of the discovery. Meitner was nominated for the Nobel Prize an astonishing 48 times in her life, for both physics and chemistry, but she never won. The injustice stung her deeply, yet she bore it with remarkable grace and integrity. She wrote to a friend, "Hahn surely deserved the Nobel Prize for chemistry. There is no doubt about it. But I believe that Frisch and I contributed something not insignificant to the clarification of the process of uranium fission." This was a characteristic understatement. Her contribution wasn't not insignificant, it was everything. Without her theoretical explanation, Hahn's results were just an inexplicable chemical anomaly. She had provided the why and the how to his what. While Hahn accepted his prize, Meitner turned her attention to the terrifying consequences of her discovery. Horrified by the use of the atomic bomb on Hiroshima and Nagasaki, she became a vocal advocate for the peaceful use of nuclear energy and a critic of nuclear weapons. She had refused to work on the Manhattan Project during the war, famously stating, "I will have nothing to do with a bomb." Her ethical stance stood in stark contrast to many of her contemporaries, cementing her legacy not just a brilliant scientist, but as a profoundly moral one. In the decades after the war, a slow process of historical correction began. While the Nobel Prize was lost forever, other forms of recognition came. She received numerous awards and honorary doctorates. In 1966, she, Hahn, and Strassmann were jointly awarded the prestigious Enrico Fermi Award in the United States, a moment that was seen by many as a long overdue acknowledgement of the trio's shared contribution. But perhaps the most enduring honor came posthumously. In 1997, the scientific community gave her a form of immortality that few ever achieve. Element 109, one of the heaviest on the periodic table, was officially named Meitnerium, symbol MT. Unlike many elements named after places or mythological figures, this was a direct tribute to a person, ensuring her name is forever etched into the fundamental language of science. Lise Meitner's story is a powerful, cautionary tale. It reveals how personal ambition, political turmoil, and systematic prejudice can conspire to write a genius out of history. But it is also a story of incredible resilience, intellectual integrity, and the ultimate triumph of truth. Her brilliance shines through the shadows of historical oversight, a beacon for all the unsung heroes of science whose contributions have been forgotten or ignored, challenging us to look deeper, question the official record, and give credit where it is so profoundly and justly due.